In this video, we are going to look at volume rotated 360 degrees about the x-axis. You will find this on page 343 in the Namibian AS-Level Mathematics textbook y equals mx plus c to success. Volume rotated 360 degrees about the x-axis. Consider the area bounded by the curve y equals x squared. Here's the curve, the x-axis, and the lines x equals a and x equals b. When this area is rotated through 360 about the x-axis, a solid of revolution is formed, and the volume of this solid is called a volume of revolution. It's almost like this picture. So I'm taking this area and I start moving it. Now, three-dimensional area, it will give you volume. So can I just before, because here I made a note here, I just want to first go through this note. Rotation of a curve around an axis forms a 3D solid. And what is a solid? It's three-dimensional. It has volume and it's enclosed by surfaces which can be curved or flat. Okay, so keep in mind. The volume V of the solid can be approximated by a series of cylindrical discs of thickness delta x, corresponding to a small increase in x, just like we did with area when we were taking the rectangles. Now it's just three-dimensional, so now it's going in a circle, so it's going to give me cylinders. Okay. And the radius y corresponding to the height of the function. Okay, so how do I work out the volume of a cylindrical disc? Because it's a cylinder. Okay, so how will I do that? Now, can you still remember if you have a cylinder? My picture is not good. I say it forms that, but what it's always giving me a what? It's area of base times the height. That's how I calculate the volume of that. So area of base times the height. So now I said the radius is equal to the function y. So what must I do with the function y? I must square it because it's area. What is the area of a circle? Pi r squared. So it will be pi function squared, and the height is that small, that little thickness, can you say, delta x. So the volume V of the solid can be found by adding the volumes of these cylindrical discs. The smaller delta x, the closer the approximation is to the volume. Just like we did, if we were making the rectangles very thin, almost like a line, then we were then the answer was closer to the real answer. So as the cylindrical disc approaches zero in width, it's tending to zero, the answer approaches the true volume. The volume V obtained in this way is defined as the definite integral of y from, so it's having boundaries, from A to B, and is denoted by, so pi r squared, that's area of base, do you see, dx, and I'm going to integrate 2x. So remember, in volume, don't forget your pi, don't forget to take your function and to square it. Okay, so this leads to the general rule. The volume V obtained when the function y is equal to fx is rotated through 360 about the x-axis between the boundaries x is equal to a and x is equal to b is given by volume, and there's my formula. Pi function squared dx. Okay, let's try an example. Okay, now if I say find the volume obtained when the shaded region is rotated through 360 about the x-axis. So this is rotated. Now, volume is pi and then the function squared, and it's between 3 and 1. So leave pi in front, it's a constant, so it can move to the front. Don't forget to take your function and to square it. And now you integrate. Plus 1, divide by that, leave pi in front, between 3 and 1. Leave pi in front, just put a bigger bracket, and then just substitute. And then you can leave even, this is more accurate than working the real value of pi. Okay, so you can leave your answer in terms of pi. And because you don't know the units, you're just going to say, I know it's volume, so it's going to be units, whatever units, centimeter, meter, it's going to be to the power of 3. Okay. I want you to stop the video, and I want you to do number 1. You can continue the video as soon as you are finished. Okay, let's start with number 1. The volume obtained when the region is bound, there's the function. It's between 0 and 3, and it's rotated x-axis. Very important. We will later come to y-axis. So let's first write down the function. That is the function. So if I want to find that volume, don't forget always your pi, okay? Then it's between 3 and 0. Then don't forget to take your function and to square it. I forgot, I said square, but I didn't write. Okay, now, because it's square, I can just multiply it out. So, square this term. Multiply this 2 with each other and multiply it by 2. So this is going to be x3, so it's going to be 2x3 plus 1. And it's going to be dx. Okay, leave the pi. I'm going to integrate now. So this is going to be x7 over 7 plus 2x4 over 4 plus x. Okay, so this is going to be pi again. I'm going to substitute now. I can just simplify that to a half. I'm just going to, as soon as I come there, I'll just write a half. Okay, so if I substitute, keep that because it's for both. So it's going to be 3 to the power 7 over 7 plus 3 to the power 4 over 2, don't forget your 2, plus 3. That's your first bracket. Let's just move it a little bit. Minus, and okay, now I'm in the bracket again. Oh, this is 0. But don't always think it's 0, especially with lengths in the next chapter. In this case, it will be 0. I'm just going to show you. And you can see now, the whole term is just going to become that 0. Okay. Now I'm just going to work it out. 3 to the power of 7 equals, divide 7 equals, oh, let's give me a fraction. So this is going to be 312, 3 over 7, plus, this is 3 to the power 4 equals, divide 2 equals, and it's going to give me 40.5 plus 3. So if I add that, ABC, I'm getting 355, if I keep the pi, 355 and 13 over 14. So therefore, the volume equals 355, 13 over 14 pi, and whatever the units will be, it will be to the power of 3. Okay, before I stop this video, you can also try number 2. Before I stop this video, I just want you just to go through this. This is just for the interesting. I'm just sharing this to you. You will see it in the textbook. So the volume of a cone, Okay, so a cone is a straight line. So you don't need to actually do it with integration if it's a straight line. But it's just interesting to see if you do it with integration and if you do it without integration, the old way, that the answers will be exactly the same. So if the area bounded by this is the formula of that straight line. The x-axis and the line 6 is rotate about, the solid form will be a cone. Due to the fact that the function is a straight line, we can calculate the volume of the cone using measuration or integration. But let's show you with measuration. What is it? It's a cone. Volume of a cone is 1/3 of volume of a cylinder. So if I just substitute, what is the radius going to be? It's going to be 3. Did you see that? Because, can I show you why? Because that's 6 and 3. You see, so that is 3. So the radius, and that is the radius. Okay, and then what will the height be? That will be the height. And the height will be 6. Okay, and I get this in terms of pi. But if I do the integration, like I showed you there, we can, then it's between 6 and 0, okay? There's my formula, remember? So I must say pi, okay, pi, and I must square the formula. That's what I did. And then I integrate, okay? So the quarter is just, and it's free, add 1, divide 3, 6, substitute, and just for the interesting, you are getting exactly the same answer. Okay, it's always just nice sometimes to compare things and to see that if I could have done it also with a straight line, it was not necessary, but that makes this just so much more true.